Hi, AB Calculus students. We're working on 2017 question number 4. Today's topic is separate and integrate. It'll be one of your questions on your quiz on Friday or Thursday, whenever I'm giving it, and it will be one of those topics that I think is going to be on the AP exam. Separate and integrate. Some of them are easy, some of them are hard. If you just looked at the 2011 question, this is very similar to the 2011 question, very hard. We don't know what we're going to get on the AP exam. But this is a separate and integrate, and let's just jump back in. And again, if you didn't watch the 2011 video, if you go back and watch it, and then try this problem beforehand, it's insanely similar. So the very first question they ask here is, write the equation of a tangent line of h at t equals 0. So they want you to write the equation of a tangent line. But what two things do you need to write the equation of a tangent line? You need a point and a slope. And you can see here they give you a point. Now before we go any further, the variables might mess you up. So if you go ahead and stop for a moment and think, what is dy dh dt? Think about normally what we use, dy dx. So in this problem, the h is like the y, and the t is like the x. So the h is like a y, the t is like an x, okay? By the way, this is part A, okay? So right here, the y is like the h, and the t is like the x. Okay, so that's our point. So we have a point. The second thing we need is a slope, and the slope comes from the derivative. So here we have dh dt, and a big mistake you can make is what I just made. This would be the slope, but here's my big problem. I just plugged the 0 in for time, but we're not plugging in for time. When time is 0, the only thing we can plug in is the h. So it's not a 0 going over there, it's the h, which is a 91. Now, could you simplify this? Yes. You could subtract these. I believe you get 64. You could take negative 1/4 of 64 and get negative 16. I'm looking at the answers. Yes, it is negative 16, but that's a little scary. Okay? So I might consider just leaving this. This is your slope. If you want to make it negative 16, great. But it's a little intimidating. Okay, let's go ahead and write the equation of a tangent line. You need a point and a slope. So instead of y minus y1, remember our h is kind of like our y, so it's h minus h1. So h minus 91 equals m, the slope. You could just use a negative 16, but if you are not sure about what that is, you can use all of this. Negative 1/4 of 91 minus 27. That's your slope. That's fine. So that's, again, y minus y1 equals m times, all this is m. This is just negative 16. Well, that's m, and then x minus x1, but here it's t instead of x. Okay, that's your equation of the tangent line, and they say use this to approximate the value when time is 3. So we're going to get h by itself when time is 3. So, again, all this could just be negative 16. And now my time is simply 3 minus 0, or simply 3. Okay? And then the minus 91 I'd have to add to the other side. So, negative 16 times 3 is negative 48. Negative 48 plus 91 is 43. So if you were all fancy, you get 43. This is just how I choose to write 43. And that's the end of part A. Alright, so now let's talk about part B. So for part B, they want us to know, is the estimate we got an over or underestimate, and they want us to use the second derivative to do that. Now we have the first derivative, we want the second derivative. Before I get the second derivative, here's what I'm going to do. First thing I'm going to do is I'm going to distribute this to both. If I distribute that to both, I get negative 1/4 h, and then a negative times a negative is a plus 27 over 4. Okay, now I'm going to take the derivative. But before I take the derivative, I'm going to do the same thing I did in the last question. What if instead they were t's? And I mean, not h's. What if they were y's and x's? Wow. All right, having trouble here. All right, so If it was y's and x's instead of h's and t's, you would realize this is implicit differentiation. So sorry. So when I went to go take the derivative of negative 1/4 y would be negative 1/4, but you'd have the chain dy dx. Since x is your main variable, y would get a chain. And that's what's going to happen here as well. You see, the derivative of negative 1/4 h is negative 1/4. But since h is not our main variable, t is, we get this dh dt. Okay, that's the second derivative, but we don't want dh dt here. So we're going to go back and replace dh dt with this. So you will notice here I replaced dh dt with all of this. And now I want to know what's happening when h is, not when time is 0, but when h is 91. So if you multiply those, you get 1/16, and you put a 91 here, 91 minus 27. And here's what I want you to notice. This answer is a positive times a positive, which is a positive. It is greater than 0. Now, why does it matter that the second derivative is positive? If the second derivative is positive, that meant my graph was concave up. And if my graph is concave up and I use a tangent line to approximate a value, values on the tangent line are below, they are underestimates of the true value. So I would say because this is greater than 0, they know that means concave up, my estimate, it is a, let's just go ahead and just say underestimate. So it's an underestimate in part A. There you go. Nice and neat and clean. All right. So that's it. And now we're going to go to the last part, part C, which is the separate and integrate part. Alright, so how do I know they want me to separate and integrate? Well, almost every time they want you to separate and integrate, they say find, and if I go back and look at my work, find a particular solution. It almost always says find a particular solution. But here, instead of saying find a particular solution, it says find an expression for g of t. Now, you need to know this question was crazy. The year it was given, 3 hours after the test was done, potato memes started going up all over the internet. If you want to, even now, just Google potato calculus memes, and then just go look, okay? Out of the 9 points, the average nationally was like 1.7 or 1.8 out of the 9 points possible. It was a crazy question, okay? But part C is a separate and integrate, but it's not a separate and integrate with this equation. They provided a new equation. They said an alternate equation is this. Now, separate and integrate. This is quite crazy for a couple of reasons. First of all, they provided something new out of nowhere. And then this negative or this negative 1 is just a royal pain. What I'm going to do is I'm going to leave the negative 1 here, and I'm going to simply multiply the dt to the other side. There's nothing else over here. And then this g part, this whole part, has to divide to the other side. Okay. That's separate, and now I want to integrate, but I don't want to integrate with this down here. If this wasn't to the 2/3, if this 2/3 wasn't here, it'd be a du over u and ln of u, but there's a 2/3 there. So this is going to be u substitution, and we can't have this u down here. So off to the side, I'm going to show you all the work we're going to do to get to this guy's antiderivative. So first thing I'm going to do is I'm going to take this piece and move it to the top. So when I move it to the top, it's now to the negative 2/3. Okay, and now I want to use u substitution. So I'm going to say, if the u is g minus 27, what should my du be? And my du, the derivative of g, is simply 1. So it's 1 dg. And what exactly do we have here? We've got 1 dg. So we're using u substitution, that's a u. So it's u to the negative 2/3 du. The antiderivative, we would add 1 to the exponent. When you add 1 to negative 2/3, you get 1/3. And then we're going to multiply by the reciprocal 3. And then we're going to finish the problem by replacing. So the u now can be replaced with g minus 27. So we have 3 g minus 27 to the 1/3. And now let's go to the other side. The antiderivative of negative, well, if it was 3 dx, the antiderivative of 3 dx would just simply be 3x. So the antiderivative of negative 1 dt is simply negative 1t. Obviously, you don't have to put the 1 there. You can just put negative t. Okay, so that's what we get when we separate and integrate. Now, we must solve for c. So what am I going to do to solve for c? Well, they give me the initial ordered pair, g of 0 equals 91. Again, when time is 0, 91 this time is g. So t is 0, 91 is g. So I'm going to go ahead and do that. And again, on the other side, I put a 0 there. When I put a 0 there, I just get this is c. So all of this is c. Now, folks, you don't have to simplify this. I'm going to simplify it just because I don't want the problem to get any bigger. This right here, this technically is c. Again, you could just say this is c, put it there, and you're done. But we have to get g by itself. So I want life to look easier. So I'm going to make life easier. This right here is 64, and 64 to the 1/3 power is 4. Therefore, c is 12. So I'm going to take the fact that c is 12 and plug it right there. Okay, so now I got this, and my c is 12. So 3g minus 27 to the 1/3 power equals negative 1t. I'm just going to call it negative t plus 12. Okay. So from here, what are we going to do? We're going to divide 3 to the other side. And I'm just going to divide, I'm just going to make it dividing by 3. I know it could be ugly. There are many steps along the way you could simplify, but you might not. And then we're going to get rid of this cube by raising it to the 3rd power. And then we're going to add the 27 to the other side. And there you go. And wouldn't it be insane if we were done? But we're not. After all that work, they say, and now, you haven't done enough. Based on this model, what's the temperature when time is 3? So after doing all this work, and you would normally stop here with a separate and integrate, we have to replace time with 3. Now, we're done. This is your answer. I mean, this was also an answer. So that's what you got when separating and integrate. That's what you got when you plugged in 3's t. Could you simplify this? Sure, it's actually not that bad. That's 9 divided by 3 is 3. 3 to the 3rd is 27. 27 plus 27 is 54. Let me just make sure 54 is right. Yeah, that's right. It's a crazy question. Remember, you're not going to get all the points on the AP exam. Or maybe someone will this year since there's not going to be as many questions. But it's going to be a crazy test. You're going to do the best that you can. And sometimes you maybe can't finish the problem. But, you know, get as far as you can get some points. Anyways, have a great day. Thanks for watching.